So let's start to look at now some software failures. Now, as we can see, the role of software is increasing day by day in our lives, whether it is banking, shopping, reservations and booking, like hotel booking, airline booking and so on. The shuttle flight programs, flight control programs, there's a lot of software in that. Air traffic management, medical diagnosis, etc. So it's like it has become part of our blood and we experience it every day in every walk of life and cannot be without it now. Does it have loose ends similar to the ones that we saw in some of the failures? The answer is yes. And now what we're going to do is look at some of these major failures. So Arian 5, RBS, Amazon. So these are some of the failure cases that I will share with you. So let's start with Arian 5. So what is Arian 5? It's a European heavy lift launch vehicle. It's part of the Ariane rocket family, an expendable launch system used to deliver payloads into geostationary transfer orbits, GTO, or low Earth orbits, LEO. So what happened? Ariane 5's first test flight, Flight 501, on June 4th, 1996 failed, with the rocket self-destructing 37 seconds after the launch. Now it had taken a decade of development costing $7 billion to make this rocket. So you can find the complete video of this at this link that I've given to you. So why did it fail? Again, there were human reasons and technical reasons. So in terms of the human reason, there was a software glitch, and I'll tell you what that software glitch was. And that brings us to the question that what was the context driving this software team, and also the skills required to do the various things, that is requirement gathering, designing and testing and so on. In terms of the technical reasons, the report that came out that said that a 64-bit floating point number relating to the horizontal velocity of the rocket with respect to the platform was converted to a 16-bit signed integer. The number was larger than 32,768. That is the largest integer storable in 16-bit signed integer, and thus the conversion failed. Now obviously in terms of the design flaw, this is a wrong software design, and in terms of the software, the materials that are there is the code which is there and the test cases which are there, which are used to test it. So definitely it was a faulty code, and there were missed test cases which could not identify this problem. Here are some of the references which you can go through. So what is the key takeaway? Again, did the people have the right context as a driver or blinded by some other? So let's think about it. For example, security of assets, reliable software, return on investment versus reuse the legacy code, legacy test cases are fine, and so on. So what was missing? Was it tested enough? And what was the context which was driving people to test it? Alright, and not just test to context to make this happen as a success. The next example I'll share is that of the RBS. What is RBS? One of the retail banking subsidiaries of the Royal Bank of Scotland Group PLC, together with NatWest and Ulster Bank. Before 2008 collapse and the general financial crisis, RBS Group was very briefly the largest bank in the world. So what happened? A bad software upgrade made RBS system unable to process payments for both individual and business customer. So what did it result in? It resulted in individuals and customers not meeting their financial commitments. So people who have automated their rent payment or their credit card payments or salary transfers, nothing of that was happening. So why did it fail? Again, let's look at the human reasons and the technical reasons. So again, in human reasons, what was the context that was driving them? Was it meeting the deadline for upgrade was the context? What about safe and reliable banking of the customers? And then of course we need to look at the skills as well, the designing, coding, testing and management. And specifically in this case, we need to, in terms of the design, see what was wrong with the design. Obviously it's not made public. And then the materials in terms of the integration, coding and test cases. So all that need to be looked into. And then the communication and the management of the whole project and the business process planning, that in case of failure, a mechanism to have a rollback so that the people don't, the customers don't suffer. And of course, the various regulations and inspections. Here are some of the references you can go through. So what is the key takeaway? Again, did people have the right context as a driver or blinded by some other context? So we need to think about that. Customers' financial commitments, emergency response management versus bugs are okay to have in the product. Achieve the milestone even at the cost of risk, and so on. So again, what was missing? Was it tested enough? Did they have the context, the right context or the powerful context to get that, really good customer experience? So this is something, again, which to me seems to be a missing component. Related to Amazon, I've covered it in the additional sessions section, so you can have a look at that. And there are, many other software failure links. For example, a collection of well-known software failures, software horror stories, top 10 most infamous software bugs of all time, highest profile software failures of 2012, top 10 software failures of 2011, and so on. And one of the interesting one was that the ATMs started to give free money at one of the locations, right? So if you were trying to, withdraw X amount, it will give you 2X. And that again was due to some software glitch. So this was quite a funny one. And then the famous Windows crash, which is there. You can follow the link which is given over here. And this is a very interesting, case where Bill Gates and his teammate was presenting the new Windows operating system, and they say how the plug and play can work very well, right? And as they were trying to demo that, the operating system crashed. So it's a very interesting thing. You can watch the YouTube video over here. Alright, so that's why it's very important to stay tuned with the regular updates and patches, which will be helping you to keep your system safe from these failures. However, how do we address this upfront? That is the key questions. You can pass on the updates and patches, which you keep on, even today keep on seeing on your operating systems or your softwares that you buy. But how do we address this upfront? And what is that critical element that's going to take care of this?